the mountain lion. The apex predator of the Americas, capable of taking down elk, bighorn sheep, even full-grown moose, an animal built entirely around the ability to kill things bigger than itself. So why does it sometimes die trying to eat a slow, waddling rodent that can't even run? If you search wildlife research databases, you'll find the same story over and over. From Wyoming to Saskatchewan to the mountains of California, a cougar attacks a porcupine, and weeks later, that same cougar is found dead. Not from another predator, not from starvation in the usual sense. Killed slowly, from the inside, by an animal roughly the size of a house cat that never even chased it. The Teton Cougar Project, a long-running research effort that has tracked more than 120 individual mountain lions across a 900-square-mile stretch of Wyoming since 2000, has documented this happening more than once. Among the studies tracked cats, hunters, starvation, and other predators sit at the top of the list of causes of death. Exactly what you'd expect for a large carnivore. Porcupines sit far down that list, but they're not absent from it. A young female cougar researchers called F99 had already survived a genuine gauntlet by the time she was 16 months old. She'd been orphaned as a kitten when her mother was killed by another lion. She'd survived an attack by a bald eagle that grabbed her off the ground. She'd shared carcasses with grizzly bears many times her size and walked away each time. Then, in the fall, she killed and ate a porcupine and seemed completely fine afterward. About a month later, she was found dead. The necropsy found the porcupine's quills had migrated through her chest cavity and into her lungs, collapsing one of them completely. The animal that survived an eagle and multiple grizzly encounters was killed by the one prey item that never even chased her. She wasn't the only one. A 15-month-old male cougar in the same research area, known as M34, was found curled up dead at the base of a tree after his first known encounter with a porcupine. His chest, neck, and face were completely covered in deeply embedded quills. He never even made it to the slow, delayed death F99 experienced. The quills killed him almost immediately. To understand why an apex predator keeps losing to an animal that can't run, bite hard, or fight back in any conventional sense, you first have to understand why the cat even attempts it in the first place. From a purely nutritional standpoint, a porcupine looks like an easy meal. It doesn't run. A cougar capable of sprinting down a mule deer has no trouble physically overtaking a slow-moving rodent that tops out at maybe 2 or 3 miles an hour on the ground. It's also substantial, up to 20 pounds of meat on a single animal. More efficient calorically than chasing something fast enough to escape most of the time. On paper, it's one of the lowest effort meals available in a cougar's entire range. The porcupine knows this too, which is exactly why it doesn't rely on speed or aggression to survive. It relies entirely on making the one weapon it does have expensive enough that most predators learn to leave it alone after a single encounter, or don't survive long enough to learn anything at all. Before you even get to a bite, though, the porcupine tries to warn you off first. When it senses a predator, it doesn't immediately swing its tail. It turns its rear toward the threat and raises its quills into a dense, visible rosette, sometimes chattering its teeth or stamping its feet as an audible warning. Biologists studying the species have found the quills themselves have a faint fluorescent quality under low light, the exact conditions when porcupines and their nocturnal predators are most likely to cross paths, making that raised rosette even more visible in the dark than it would otherwise be. The entire display exists to end the encounter before any contact happens at all. Only if a predator ignores every warning and gets close enough to actually make contact does the porcupine finally swing its tail, and even then, it isn't attacking. It's simply presenting the one part of its body built to make touching it a mistake. To understand why that mistake is so catastrophic once it happens, you have to understand what a porcupine quill actually is. A North American porcupine carries around 30,000 of them, and for a long time, people assumed the danger was just about quantity, a numbers game where enough sharp points eventually does real damage. That's not what's actually happening. In 2012, a team of researchers led by bioengineer Jeffrey Karp, working across Harvard-affiliated labs and MIT, took actual porcupine quills into a lab and tested them the way you'd test a medical device. They measured the exact force it takes for a single quill to puncture skin and compared it to a standard hypodermic needle of similar diameter. The quill needed just over half the force to go in. Under a microscope, the reason became obvious. The last 4 millimeters of every quill are covered in microscopic backward-facing barbs, hundreds of them, layered like the teeth of a serrated knife. Those barbs don't just anchor the quill once it's inside. They actively help it get in, concentrating pressure at tiny points along the tip, so it slices through tissue almost effortlessly. The same structure that makes a quill 4 times harder to pull out than a barbless one also makes it easier to push in than a needle a doctor would use on you. It's not a spike, it's a self-inserting anchor, and once it's past the skin, that same backward geometry means it isn't coming back out the way it went in. The researchers didn't stop at measuring the quill itself. They compared it against quills from African porcupines, a related species that never evolved barbs at all, relying purely on length and stiffness for defense. The barbless African quills needed roughly twice the force to penetrate skin, and pulled out almost freely once they were in. It's a controlled natural experiment that isolates exactly what the barbs are doing. They're not decoration, and they're not simply there to make removal painful as a side effect. Push and pull are 2 completely separate problems in materials engineering, and the North American porcupine's quill somehow solves both simultaneously. A microscopic feature Karp's team has since called functionally unique among any biological structure they've studied. That's only half the design. The other half is what happens after the quill is already inside, and it's the part that actually killed F99 and M34. A lodged quill doesn't stay where it landed, because the surrounding muscle contracts and relaxes with every movement the animal makes, and because those backward barbs only let the quill move in one direction. Ordinary movement drives the quill deeper over time. Researchers have documented quills migrating several centimeters through tissue over the course of weeks, working through fat and muscle the way a fishhook drifts through a sweater with every wash. It doesn't need to be aimed at a lung or an artery to eventually reach one. It just needs weeks and a body that keeps moving. Veterinary case reports describe the same migration in domestic dogs that survived an initial encounter seemingly unharmed, only for a stray quill to surface weeks or months later in a completely different part of the body, or to never surface at all, ending its journey somewhere far more dangerous than the muzzle it first punctured. So why doesn't the cougar simply pull the quills out immediately, before any of that has time to happen? Because a mouthful of 40 or 50 barbed anchors, each one independently resisting removal, each one hooked backward into soft tissue, isn't something a cat's tongue and teeth are built to solve. Pulling one out often just drives the neighboring ones in deeper. For an experienced adult, the damage might stay superficial, healing over with a permanent scar and a lesson learned. For a young, inexperienced cat working through its first porcupine, or an unlucky adult that gets a mouthful in exactly the wrong place, there's no clean way to undo the mistake once it's made. Here's the part that should complicate the whole story. The porcupine isn't even trying to fight. Porcupines are not aggressive animals. Wildlife biologists describe them as one of the most passive mammals in North America, solitary, slow-moving, and entirely uninterested in confrontation. When a porcupine senses a predator, its first response isn't to attack. It's to turn its back, present the dense rosette of quills covering its rear and tail, and simply wait, sometimes chattering its teeth or stamping as a warning. It doesn't chase. It doesn't lunge. If given any option at all, it would rather waddle away. The tail swing, the one motion that actually drives quills into an attacker, is a last resort, deployed only once something is already close enough to touch it. The porcupine has no offense. It has exactly one defensive mechanism, and that mechanism happens to be so mechanically refined that it can kill one of the most capable predators on the continent by accident, weeks after the encounter is already over. This isn't unique to mountain lions either. Across the ocean, researchers studying African lions have documented the same pattern for over a century, and the historical record runs even deeper than the modern one. As far back as 1656, an official with the Dutch East India Company stationed at the Cape of Good Hope wrote in his diary about 3 separate lions found stuck with porcupine quills, a detail thought interesting enough to record centuries before anyone had a scientific framework for why it mattered. A 2019 study led by Julian Kurbis Peterhans at Chicago's Roosevelt University reviewed decades of documented lion-porcupine interactions and found roughly 40 cases of lions seriously injured by porcupine quills and another 10 killed outright, sometimes when a quill pierced the heart or a major artery directly. The most striking cases in that research involve some of history's most infamous man-eating lions. In 1898, 2 male lions in Kenya killed a number of railway workers over a period of months. Officially documented deaths were in the dozens, though the famous popular account behind the book and film The Ghost and the Darkness claims a much higher toll of over 100. When researchers finally examined their preserved skulls generations later, they found porcupine quill fragments embedded in fractures within the lion's teeth. In a separate case, the so-called man-eater of Darajani, shot in 1965 after attacking a hunter, was found with a porcupine quill that had penetrated more than 6 inches into its snout, nearly reaching the brain. CT scans on these skulls later revealed bone infections severe enough to impair the lion's ability to eat normal prey, or in the case of the Darajani lion, to even smell it. Researchers now treat porcupine injuries as a genuine warning sign, a physical condition that can push an otherwise capable predator toward the kind of desperate, opportunistic hunting that ends with it attacking people instead of the animals it evolved to hunt. The same passive rodent quietly killing research cougars in Wyoming has, indirectly, been linked to some of the deadliest man-eating lions in recorded history. There's an odd twist to all of this that has nothing to do with predators at all. The same barbed geometry that makes a quill so dangerous once it's lodged in a cougar's lung is now being studied by surgeons. Karp's team used their measurements of quill penetration and removal force to design experimental medical staples and adhesive patches, aiming to build surgical tools that go in with less pain than a normal needle, the exact mechanical advantage that makes the quill so effective in the first place. A trait that evolved purely to make a slow, defenseless rodent survivable to walk past a predator is now sitting in medical engineering journals as inspiration for how doctors might one day close your wounds. None of this means the mountain lion is actually helpless against porcupines, and it's worth being fair to the cat here. Cougars prey on porcupines regularly, and most of the time, nothing goes wrong at all. Experienced adult cats have learned to flip a porcupine onto its back and open it from the unarmored belly, avoiding the rosette of quills across its spine and tail entirely, a technique that has to be learned rather than one they're simply born knowing. Researchers who study cougar diets describe porcupines as a fairly ordinary prey item in areas where the two overlap, eaten across a mountain lion's entire life with no incident. Older, experienced cats in porcupine country often carry a scattering of old scars and a face full of tiny, permanent scar tissue from lessons learned early and survived. F99 and M34 aren't the rule. They're the tax that gets collected occasionally when a young cat hasn't learned the technique yet, or an experienced one simply gets unlucky in a single strike that goes in at the wrong angle. The porcupine doesn't win most encounters. It just makes losing catastrophically expensive on the occasions when it does. Expensive enough that across an entire research population tracked for decades. It's still there on the list of causes of death, sitting quietly below the hunters and the rival cats, and the starvation, waiting for the next cat that hasn't learned yet. And that's really the whole lesson sitting inside 2 dead research cougars in Wyoming. and a string of injured lions stretching back to a Dutch colonial diary from 1656. The porcupine has no claws worth mentioning, no speed, no aggression, and no interest whatsoever in fighting anything. Every part of its behavior, right up until the very last second of contact, is built around avoiding a confrontation entirely. It would rather waddle away. It would rather rattle its quills and stomp and hope you take the hint. It never once has to win a fight in the way people usually picture winning. No claws locked with claws, no chase, no moment of dominance. It only has to make sure that the one time a predator ignores every warning it offers, the cost of that decision doesn't arrive immediately. It arrives quietly, in a lung, weeks later, long after the porcupine itself is already dead and forgotten, and the predator thinks it already won. That's a strange kind of power to hold in the animal kingdom. The ability to lose every single encounter in the moment and still occasionally come out ahead once the moment is over. Most predator-prey relationships get settled instantly. Something runs, something catches it or doesn't, and the outcome is obvious to anyone watching. The porcupine breaks that pattern entirely. It offers no resistance a predator can actually see coming, no display of strength, nothing that reads as dangerous the way a bear's roar or a snake's rattle does. It just quietly waits with the one tool precise enough to occasionally kill something 20 times its size, on a schedule the predator can't predict and won't understand until it's already too late to matter. You don't have to be fast. You don't have to be strong. You don't even have to try to win. You just have to make sure that whatever kills you also, eventually quietly, kills the thing that killed you too.